So we've had a request for some more videos that walk us through some compound interest problems. And we have a problem here. Brenda received $1,000 as a graduation gift, and she invested it into a savings account with an annual interest rate of 4.7, and this is compounded semi-annually. She went about her life and didn't look at the savings account for 17 years. How much is now in the account? So what we're going to do is we're going to use, of course, this is exponential relationships. We're going to use y equals a times b to the x, but we need to kind of look at what this whole semi-annually, okay? So that means that we get interest deposited twice per year. So we're going to get interest after 6 months, and then we're going to get interest after another 6 months. So that means that there are two chunks of 6 months that we're talking about that actually start accumulating when the interest is deposited. So let's first look at our interest rate and how much we are actually earning within a 6-month time period, because that is the semi-annual deposit. So if she's getting 4.7% and we take that and divide it by 2 because it's 2 deposits per year, we would end up with a deposit of 2.35% every time there is a deposit, which is every 6 months or twice per year. Now this is, as we notice, this is in percent format, so we do need to convert it into a decimal in order to put it into our equation. So we're going to move our decimal place over 2 places, fill that in with a 0, and so our new decimal version of an interest rate is 0.235. And of course we add that to 1 to make the whole, so we get a growth factor of 1.0235, and we can now write our equation. So y equals, or money equals, depending on how you're looking at it, the a value is the starting point, and that is the $1,000 that she received. So let's go $1,000 times the growth rate of 1.0235, and then it's to the, and this number must reflect the number of times that we received a deposit. So it's not 17 because it's twice per year, once at the end of 6 months and once at the end of each year. That means we're getting 2 deposits every year, so we need to take 17 and multiply that by 2. Okay, so that would actually be 34 as our exponent right there. And this is truly just problem solving and thinking through logically. So our equation, y equals $1,000 times the interest rate, 1.0235, to the 34th power. We're going to just put that in our calculator. It's calculator ready. And if I put that in my calculator, I end up with $2,202.86, which is kind of cool because we didn't do anything.